Usually we have it. Sometimes the audio goes. I don't think so. I think as long as we have this on, what if we have that unmuted? Up there.
There's several on there, but it's something about Raspberry Mike presentation 2022. So,
Oh, they are. Other room. Other one, it's just an all show over there, so it starts at 3:30 in the other room. Get started. And after that, I want to.
good at myself.
Hey everybody, we are going to get started over here in the Whatcom Family Farmers Room. Our first speaker is Chakradhar, and he's got updates from the berry and potato pathology program. Thanks, Chakradhar.
Good morning, all. My name is Chakradhar, and I'm a plant pathologist working with Washington State University. I work at WSU-Whatcom Research and Extension Center. And the goal with this presentation is to give you a snapshot of the research that is being conducted in my program, which I started in February of 2021. So I'm close to 2 years in this position. Currently, my program focuses on 3 blueberry diseases: mummyberry, botrytis, and blueberry shock. And I'll walk you through all the different projects that are being undertaken in my program right now. So it's a common practice among growers to go with the calendar-based schedule application of fungicides for protecting the young vegetative and floral buds and to protect it from the primary inoculum from the mummyberry pathogen. And so to help growers better decide when's the right time to apply these initial fungicide sprays to manage the primary inoculum of a mummyberry disease, we were working on a project to determine when to initiate these sprays. So the sprays that are being done are applied at the right time. So this project was funded by the Washington Blueberry Commission. It's based on the data that we collected for 5 years from 2016 to 2019 and in 2021. And we collected data from four field sites, one in Whatcom, Skagit Island, and Snohomish counties. And based on the disease development data that we collected from these four locations and from 5 years, we developed a model, and currently it is available for users to freely access through the network. And we are really excited to share this availability of this model with the growers. And hopefully, I think the growers would take advantage of this model, which is present on the network. Then I would also like to mention that this model is in beta version, and so I would really appreciate if the growers can start utilizing it, and if they find any glitches or if they have any suggestions to improve the user interface, if they can let me know, that would be really great. So just to quickly walk you through this. This model, once the user logs in, they get access to all different kinds of models that are present. If you scroll down and go to the Mummyberry model and select a weather station which is closest to your field, then the models puts out this output. There are two panels here. The bottom panel provides you the probability of finding apothecia on a particular date. So if you hover along this graph, you can see this box, and it provides you the information about the date when a particular date, and then it provides the data regarding the air temperature, rain, and then also it provides the probability of finding apothecia for two management regimes. One is a low management regime, and the other one is a high management regime. If you, in the upper panel, you can see, you can also find the information regarding the infection risk that's associated on that particular date. For example, if on this, in this particular panel, a square box, you can see that on March 2nd, 2022, there is a 14% probability of finding the apothecia. And if you can see that the infection risk is about 30.5%. So based on these, I hope the growers can find advantage to know when it is right time to take those management practices that they are currently working on. In addition, my program is also providing weekly Mummyberry updates to the growers, starting from mid-February through the end of April. And these Mummyberry updates are being currently disseminated through the Whatcom and Skagit County Extension offices. And I want to thank Chris and Don for helping me to disseminate this information to the growers. If you have any suggestions regarding these updates, please let me know. And yeah, I would appreciate any feedback about this as well. The next aspect that I'm currently working on is to develop a screening protocol to select for resistance or low susceptibility to Mummyberry disease. So this project is being done in collaboration with Lisa DeWetter and Claire Louis from USDA ARS. They have provided Claire Falkrick Farm Nursery as well as the Bristol. They have provided plants of different genotypes, which are displayed here. All the ORS genotypes, these are from the blueberry breeding program from the USDA in Oregon. And the other commercial cultivars, Aurora, Blue Jay, Calypso, Duke, Liberty, and Northland, are provided by Fall Creek Farm and Nursery, and Lucy is provided by Bristol. So thank you for donating the plant material to us. Currently, these plants are being grown in a screen house, and this year we were able to screen these different genotypes for mulberry fruit rot resistance. And just quickly going over the methods for this, we collected inoculum from a field. We collected the shoot spikes and collected the secondary inoculum, which is the conidia. And then we also collected pollen from the flowers, and we inoculated the flowers in each pot, and then followed by the pollination. And then we had cut open the green fruit and observed the signs of the pathogen, which you can see here as a white mycelial mats in the fruit that's present in the fruit globules, and we measured estimated the disease incidence, or more specifically the fruit rot incidence. And these are the preliminary data from that experiment. You can see here in the bottom panel, you can see the disease incidence. On x-axis, we have different genotypes, and on y-axis, we have the disease incidence expressed in percentage. And since these plants were obtained from different sources, the plant age differed, and so which resulted in the different total number of fruits that we were able to harvest from these plants. And so in the top panel, you can see the total number of harvested green fruit from each genotype. I would like to draw your attention to these three genotypes, the Duke, Northland, and ORS 587-1. All these three genotypes, there isn't any difference in the total number of green fruits harvested. As you can see here, they share the same letter, the B letter here. But if you see in the bottom panel, Duke and Northland showed the lowest fruit rot incidence compared to ORS 587-1, which is an advanced breeding line from the USDA germplasm. Yeah. So as I said, this is the first year, and it's a preliminary study, but the current experimental procedure was useful for continued screening of these genotypes, which we'll be continuing to do in the next year as well. And in addition to fruit rot evaluations, we will also be screening these genotypes for shoot spikes, so which is a primary infection. So what we did screen is the fruit rots, which is a secondary infection. So hopefully next year we'll be able to share more data on this project. One of the concerns that the growers expressed was that the growers have been repeatedly using the fungicides, DMI fungicides, to manage the primary infections of the mulberry disease, and they have been applying the same fungicides from the same class year after year and back to back. And so one of the concerns that they expressed is to understand if the pathogen has developed any resistance to these fungicides in the DMI class. And so to test this, I have, for the past 2 years, I have obtained 165 isolates from different fields. And as you can see here, in 2021, we were able to obtain 24 isolates from 2 fields in Whatcom and Snohomish counties. And in 2022, we were able to obtain 141 isolates from fields in Whatcom, Skagit, Snohomish, Clallam, and King counties. So currently, of these different 9 fields, only 1 field is conventionally managed, and the rest of the fields are either low managed or organically managed. So we have this culture collection, and so the next step for us to do is to actually determine the in vitro sensitivity of these isolates to DMI fungicides, which we are currently, it's a work in progress. As you can see here in this 2 images, we have different concentrations of the fungicides that were added to the media plates, and we inoculate the pathogen onto these plates, and we measure the how the colony diameter, and then based on this, we estimate the EC50 values and determine whether a particular isolate is resistant or susceptible to that particular fungicide concentration. So again, this is a work in progress, and I'll be able to share more information by next meeting. So moving on to the next disease, it's the bronchitis fruit rot. Again, it's a big problem for Western Washington blueberry growers. And the last survey for bronchitis fungicides susceptibility was conducted in 2015 by Tobin Peaver, who is a small fruit pathologist who retired 2 years ago. And they showed that these bronchitis populations are structured based on the field level management practices. With this study, they have only obtained isolates from 7 blueberry fields. And so we wanted to expand this, and we wanted to determine the current status of the bronchitis isolates and their sensitivity to newer fungicides that are being used by the growers. And another important thing is, like, we want to do this testing in a high throughput scale. And so in order to accomplish this, we in 2022, we sampled from 35 fields in Washington. 23 were from Whatcom, 11 fields from Skagit, and 1 field from Snohomish County. And we sampled 13 blueberry fields from Oregon State as well. So this is a project that's being done in collaboration with USDA researchers Virginia Stockwell and Jeff Dion. Of these 50 fields, they covered different blueberry cultivars such as Duke, Rika, Blue Jay, Liberty, Draper, Calypso, Blue Crop, Hardy Blue, Elliott, and Legacy. So we are trying to capture, get the data from several different fields spanning different cultivars, and also these fields were managed by growers, and their management regimes also vary a lot. And so hopefully we'll be able to get a good data set that we can provide data on. And from the Washington fields, we sampled 3 times, one at the early season, just at the beginning of the growing season. The second sampling was done at the green fruit stage, and the third final sampling was done at the mature fruit stage. So currently, we were able to obtain like 900 long-term stock cultures of bronchitis. So we have this huge culture collection that we have obtained this year, and we have also developed the proof of concept studies to do testing, the fungicide sensitivity testing. So the conventional way to test this fungicide sensitivity is to amend these media plates with different concentrations of the fungicides and then measure the colony diameter. So this is, this involves like a lot of manual procedures for data collection, and this also involves a lot of consumables as well. As you can see here, these are like 90 different plates, but we want to make it more simplified and do it on a high throughput scale. So we are working on a protocol where we can do this testing on a simple, this 96 well microplate, as you can see here. And we are using a micro-well plate reader to collect the data. We finished the proof of concept studies, and we are all set to screen all the 900 different isolates that I showed you in my earlier slide. And one of the some advantages with this approach is that it's automated, and we use less consumables, as you can see here in this image. Just a small plate, and you get the data. And it takes less time for collecting the data because it's all automatic and done by this plate reader. So the next step with this project is to continue sampling in 2023, and so we can obtain additional isolates. So the goal with this project is to see if there is a change in the population structure of this botrytis within a growing season, and also like how it is the fungicide sensitivity status is changing in between years as well. And we'll be using this high throughput method to screen multiple fungicides that are being used by the growers, that are being commonly used by growers in Washington and Oregon. So more to come about this project will be shared in the next conference. The third project that I'm currently working on is on blueberry shock. So, so what we currently know is that once plant is infected with the blueberry shock disease, then the plant recovers and there will be no issues. But in the recent couple of years, there are reports of plants showing these blueberry shock symptoms repeatedly, and we are currently calling it as recurrent shock. The virologist, plant virologist Demeter from USDA is currently working on, and they're trying to characterize what are the different kinds of viruses that are involved in this disease reactions. And we wanted to expand more on this particular topic, and we want to see like how this plants that are showing this recurrent shock, how they are progressing in a field, and we are going to do this using an aerial imaging approach. This project is done in collaboration with Chris Benedict, and for this we identified 3 fields which planted to Rika, blue crop, and Draper cultivars, and all these 3 fields have a history of a blueberry shock. And we used a RGB sensor which is mounted on a drone, and we flew this sensor on these fields 3 times during the season from mid-May through late June. And so in total, we had 9 flights that we did this year. In addition to that, we also did the ground truthing. And so for that, we assessed, we walked through several rows in each field. And during this process, we assessed 10,000 plants from all the 3 fields at each sampling time point. So 30,000 plants, and we were able, and at each time, whenever the plants were showing these typical symptoms, we sampled those plants and we brought them to the lab, and then we tested these for, at this point, we tested only for blueberry shock virus. These are the preliminary results from that study. We were able to detect the blueberry shock virus from 86% of the samples that we collected from these 3 different fields. And as you can see here, I said like we did the sampling at 3 different time points. And you can see that the number of new plants that were showing the shock symptoms, they decreased over time. For example, here at the first sampling time point, which is like mid-May, is a time where we saw more number of plants with the shock-like symptoms, and that number got decreased by the 3rd sampling time point. So the next step with this project is that we will continue to we have obtained a baseline data for to continue our research in 2023, and because while collecting the samples, we also noted the GPS location of these particular disease samples, so we can go back to the same plant the coming year and see how the plant is, if the plant is showing the symptoms or not in the next year. And this would be a great way to know how these recurrent shock symptoms are spreading between the years. And so we are also currently working on a modeling approaches to validate the ground truth data with the aerial imaging data. So finally, I want to thank my team members, Dana, Babette, Roshni, Emma, and Adam. I want to thank our collaborators with the USDA, Virginia Stoffel and Jeff Dillon, Chris, Lisa, and a lot of grower cooperators, as I mentioned. We sampled from 35 different fields, and I want to thank all the grower cooperators for helping us pull out the samples and helping us with our research. Finally, I also want to thank our funding agencies, Washington Mulberry Commission, Northwest Center for Small Fruit Research, Washington State Commission on Pesticide Registration, and then Northwest Agricultural Research Foundation. Yeah, thank you. And if you have any questions, I'll be happy to answer.
Any questions for Chakradhar? Okay, thank you, Chakradhar.
Thank you.
Next up, we're going to hear from Alan Schreiber. He's going to be telling us about controlling of blueberry insects and mite pests.